So what is this thing we call a log? Well, log is short for logarithm, and it is not referring to that thing that happens when you cut down a tree and you cut off the top and then you pile them up. No, we're not talking about a pile of logs. I don't even know how you'd pile them up. No, okay, anyway. No, that's not what we're doing here. Logs in math are short for logarithms. I'm not sure exactly where the word logarithm comes from, but a logarithm is the inverse function for an exponential. So it's the inverse of an exponential function. Now, an exponential function is where your variable is in the exponent. So if you've got 2 raised to the x equals 8, you could solve this because the 8 can be rewritten as 2 to a power. And since no two different powers of 2 would be equal to each other, then we can just drop the 2's and say, well, then x equals 8. But what if you've got 2 raised to the x equals 7? It's not humanly possible to figure out what power of 2 would give us 7. But because you know that this graph's like this, and you know the domain is all real numbers, there is some point here that has some power of x that gives you 7 as the y value. If we know, of course, that 7 is between 4 and 8, and you know that 4 is 2 squared and 8 is 2 cubed, then there are going to be values between 2 and 3 that would be the exponent of 2 raised to the x, so that 2 raised to the x would be 7. In other words, 7 is between 4 and 8. So here the x has got to be between 2 and 3 if 2 raised to the x is going to equal 7, if these two are the same thing. So there's some value between 2 and 3 that will make 2 raised to that power equal 7. But as I said, it's not really humanly possible to determine exactly what that is without the use of logs. So logs work like this. If the logarithm is the inverse operation for an exponential, where your x is in the variable, because if we've got 2 cubed is equal to 8, if we go back to that, we could solve this for 2 by taking the cube root of both sides. Cube root of 8 is 2. The cube root of anything cubed is going to be whatever was in the radical. So we can reduce this down to a cube down to a 2. We can get rid of the exponent by doing the cube root. But if we have 2 raised to the x equals something, we can't do the xth root because we're not any better off than when we didn't know what the exponent was to start with. So that doesn't help. There's no way to get a hold of this exponent by taking a root if we have no idea what the exponent is. That's why we have to have an inverse function for exponentials. The way we define it is the log base b, I like to use b for the base, of x equals y, if and only if b raised to the y power equals x. B, it's big now, raised to the exponent y equals x. This is the definition of a log. The log, or logarithm, but we say log for short, the log base b of x is the exponent you must raise b to make it equal x. The log is the exponent. So the log is y. Which log? Well, it's the log base b of x is y. So we could write the log base 2 of 8 is 3 because 2 raised to the third power is equal to 8. When you're going to convert back and forth from an exponent to a log, you have to jump back and forth across the equals. If we have the log base 4 of 16 equals 2, that's true if and only if 4, start with your base, raised to the, jump over here, raised to the second equals, jump back, 16. So you got to start here, jump to here, equals this. The log base 3 of 81 is 4. Write that as an exponent. You start with a 3. And this is called a base, whether it's written as a logarithm or as an exponent. In this problem, 4 is the base, 2 is the exponent, 16 is the answer, basically. So the base raised to an exponent equals some number. Here, the base of the log of the base of this number has to equal this, where this is the exponent that you put on the 3 to make it equal 81. So 3, jump over, raised to the 4th, equals, jump back, 81. And we know this is true. We know this is true. We're used to these. What if we had 3 cubed is 27? Write that in logarithmic form. Well, then you write log And then whatever being raised to the power is your base. Now, this could be written as 27 equals 3 cubed. The base here is whatever is being raised to the power. So this is going to be the log base 3. Either way, you then jump over the equal sign. So we start with the 3, jump over of 27 equals, jump back 3. What if we had 5 cubed equals 125? This is true, correct? To write this as a log, you write the word log, and then you write whatever's raised to the power. So this would be the 5, and then you jump over the equals of 125 equals, jump back, the only thing we haven't used is 3. Log base 5 of 125 is 3 because 3 is the exponent we have to apply to the 5 to make it come out to be 125. What if we don't know all the numbers? The log base 2 of 32 equals what? Well, to solve this, we could put an x here. So 2 raised to the x equals 32. Now, we could solve this by figuring out what power 2 has to be raised to make it equal 32. And 2 to the 5th actually is 32. So I can drop the bases and say, well, x equals 5. On the other hand, I could have plugged this into a calculator. Your calculator is going to have, or should have, 2 buttons. One says log, and one has ln. It might look like it's an IN. This is a log with a different base. This is a log base 10. So this is automatically a base 10. This is the same thing as log base E. We're going to talk about how to use the calculator later. But for the time being, I want you to get used to being able to work with logs by connecting them with exponents. What if I had the log base 2 of x equals 16, equals 4? Almost got too big there. Okay, how do you figure out what x is? Well, if you're stuck, rewrite it as an exponent. So this would become 2, jump over, raised to the 4 equals jump back x. And since 2 to the 4th is 16, we know x is 16. We could even have something like the log base b. Now we don't know what the base is. 25 equals 2. Now I couldn't use the log on the calculator to get this because I don't know what to take the log of. And I couldn't use the log on the calculator to get this because I don't know what the base is. You change the base, it's going to change the answer. But I can rewrite this as an exponent by saying b squared equals 25, and then lo and behold, we all know that b has to equal 5, right? So that's essentially what a log is. First thing you need to do is get comfortable with switching it back and forth from the log format to the exponential way to write it. It's like the difference between fractions and decimals. It means the same thing, it's just another way to do it.